am Massimo Centemero, Managing Director of Italian Composting Council.
So let's talk about compost quality, marketing and application. Let's start again with this global map showing the desertification potential all around the world. And as you can see, the Mediterranean area is deeply affected and potentially vulnerable to desertification in many areas. This map shows the detail of areas in the Southern Europe area, of areas very sensitive to desertification with this desertification index. And again, there are many regions all around the Mediterranean area. In the map showing the soil organic carbon content prepared by the European Soil Bureau, you can see that organic carbon is lower than 2% in almost all the Mediterranean areas. And that's really a low amount of organic content, which makes the soil very vulnerable to climate change and desertification issues. The risk of soil degradation is high. Nearly 75% of the total area analyzed in Southern Europe has a low or very low soil organic matter content. It has been calculated that in the European Union, 52 million of hectares of soils, over 16% of total surface, are damaged by degradation forms, according to UNEP. Soil organic matter content is so low that we have to be very careful, because we are getting to a no-return point. What does it mean? The point of no return has been addressed as the point when soil organic carbon falls below 1%. At that level, soil structure is too damaged to continue any biotic production, so it becomes really a desert. The European Commission has addressed soils with less than 1.7 of soil organic matter in a phase of pre-desertification. And also other authors has addressed the value of 1% as a threshold for sustainability. Most importantly, when soil organic content falls below 1%, other degradation processes take place, such as erosion and salinization. Let's look at this chart. Soils are degrading, are going to desertification phase, but cities are increasing their production of waste. So the urban and rural relationships is to be carefully considered. There are environmental and health problems in urban areas due to unmanaged waste, for sure, more specifically in low-income countries. And in the very areas around the cities, there are deserts. So compost may be the link for the solution of two different aspects: overproduction of waste in urban areas and lack of organic matter in soils in rural areas. But what is compost? Who is this unknown? We have to address chemical and physical property of compost to understand exactly what it is. We can compare properties of manure and of peat, which are commonly used as soil improvers. And we can state that compost is in the middle between them. Manure has a high nitrogen content, peat has a low nitrogen. Manure has a high salinity, while peat is low. Manure is not so stable, while peat is very stable. And again, about odor. Manure has odor, but it's not important, while peat has no odor. So typically manure, which has been used by all the population since thousands of years, has been used as a fertilizer in field crops, while peat has been used for gardening. We have to point out that peat is coming from very far away production sites with high environmental costs. So compost is in the middle because it has different chemical and physical characteristics that lie in the middle of manure and peat. So compost is also a material that can be also transformed to make organic fertilizer, soil improvers and growing media. The potential benefits of compost for field crops are manifold. Starting from soil improvement, compost guarantees to improve the structure of soils, to increase water retention capacity, permeability, and most importantly, protection against erosion. It also has a fertilizing value, like apporting to the soil nitrogen, phosphorus, potassium, and other micronutrients. Another important feature is that it stimulates biological activity by also inhibiting soil-borne diseases with a direct effect and also an indirect effect by stimulating soil biological activity. And also it can inhibit plant diseases by compost extracts and the induction of resistance. We would like to stress this fact of water retention capacity, because if you see on this chart, it's about water stress indicator in the Mediterranean area, and we can see again how water is overexploited or heavily exploited in many regions of the Mediterranean area. That means that many of those areas we cannot afford exploiting water resources for agriculture so much, because it has already been overexploited. Talking about nutrients and fertilizing properties, compost has different nitrogen forms in itself. It has a lot of organic nitrogen. Total nitrogen is about 2.6% of dry matter. The fact that it has a lot of organic nitrogen make it very valuable as a source of long-term nitrogen. We can say that it has a readily available content. Also some nitrogen made available during the first year, and also a slow release nitrogen, which is really important for crops. The role of the nutrients is so important when compared to the tonnage of compost that is delivered to the soil. We can see that by applying 20 to 40 tons of compost per hectare, we are delivering basically 50 to 100 kilograms of nitrogen per hectare. All the nutrients delivered by compost has an important value, not only because it's substituting mineral fertilizer like NPK fertilizers. We can do some calculation by spreading 10 tons per hectare of quality compost. We are delivering a substituting value of 40 euro per ton of dry matter, which is really something high. But also we have to address the fact that some of the mineral fertilizer are relying on some resources that now are becoming less and less available, like phosphorus. And in this respect, we would like to show you a short video about phosphorus and the crisis of phosphorus around the world.
Phosphorus. We all need this nutrient to exist. It is an essential ingredient of the fertilizers we use for feed and food. There is no substitute for phosphorus. It is irreplaceable. 90% of the available phosphorus is used for fertilizers, and therefore it is essential for worldwide food security. But we are running out. Where does phosphorus come from? Raw phosphorus is obtained by mining phosphate rock. These mines are mainly located in China, the US, and Morocco. In Europe, hardly any raw phosphorus is available, except for a very small quantity in Finland. Due to the increasing world population and rising prosperity, the demand for phosphorus is growing rapidly. Besides that, more and more phosphorus is needed to grow plants for biofuels. But where does phosphorus go after use? We waste it. Phosphorus disappears from the food chain as organic waste, such as animal manure, food waste, and even our own pee and poo. Waste phosphorus pollutes rivers, lakes, and oceans. This process of eutrophication is a leading threat to water quality around the world. Eventually, the world's reserves will run out. But the exact moment of depletion is uncertain. Many factors will influence this: an increasing population, the growing demand for meat and biofuels, and new discoveries of phosphate rock. We depend on countries outside Europe for our access to phosphorus reserves. Without access to phosphorus, Europe will be unable to feed its own population. For our own food security and environment, we have to take action today. This is what we call the Phosphorus Challenge. We have to use less, recycle more, and cooperate. Find and share solutions on the online phosphorus platform. Register now for the European Sustainable Phosphorus Conference in Brussels.